This question is from GATE 2020, Mechanical Engineering paper set 1, question number 42. A slot of 25 mm by 25 mm is to be milled in a workpiece of 300 mm length using a side and face milling cutter of diameter 100 mm, width 25 mm and having 20 teeth for a depth of cut 5 mm, feet per tooth 0.1 mm, cutting speed 35 meter per minute and approach and over travel distance of 5 mm each. The time required for milling the slot is dash minutes. Let's write all this given information first. So the slot is 25 mm by 25 mm. Size of slot 25 mm by 25 mm. Length of the workpiece is 300 mm. Let's write it L equal to 300 millimeters. Diameter of milling cutter is 100 millimeter. Let's write capital D is 100. Width of this cutter is 25 millimeter. Let's write capital B is 25 millimeter. Number of teeth is 20. Let's write N equal to 20 teeth. Depth of cut is 5 millimeter. Small d 5 millimeter. Now feed per tooth is given 0.1 millimeter. Let's write it as F, feed per tooth 0.1 millimeter. This is per tooth. And cutting speed is given. Let's write this as V, 35 meter per minute. Approach and over travel distances are given. Let's write AP is equal to 5 millimeter. And over travel, let's write it as OT, that is also 5 millimeter. This is all the information that is given here. Now let's try to calculate the time required for milling the slot. Now time required for milling the slot will be calculated using the velocity. So we know that milling speed for single pass. For a single pass it will be length of the cut upon the time required for milling. Let that be T or Tm. With the terms of the tool we can calculate this milling speed. So that will be nothing but the feed will be feed rate per tooth F into the number of tooth N into RPM capital N. This will also give us the milling speed. Now let's substitute whatever we have. So we have this side of the equation as the given things here. F into N into capital N. F is 0.1, number of tooth are 20 into. Now we'll have to calculate capital N using the velocity. So that can be calculated here. Velocity is nothing but pi d n. Pi d is the circumference into the RPM gives us the velocity. We do divide by 60 if we have the velocity in meter per second. But here we are having the velocity in meter per minute itself. So this is in revolutions per minute. This also in meter per minute. So we'll keep this as pi d n. From here we can calculate n as v upon pi d, which comes out to be 35 upon pi into 100 millimeters. 35 upon pi into 100 millimeters has to be converted to meter because this is in meter per minute. So it is 100 into 10 to the power minus 3. This gives us n as 111.4085. So let's substitute it here, 111.4085. This will be equal to length of cut upon Tm. On this side we are calculating the length of cut. So we'll have to add up all the necessary entities. First is length of the workpiece, which is nothing but 300 millimeters. Plus there's radius of the tool. So diameter is given 100, radius will be 100 by 2. Plus the approach allowance given, that is 5 millimeter, and plus the over travel given, that is 5 millimeters. This gives us the length of cut as 360 divided by Tm. From here we can calculate Tm, which is the milling time per pass. So let's calculate that. Tm from here. Putting all this in the digital calculator. This side we have 360 in the numerator divided by. This side it turns out to be 2 into 111.4085 gives us 222.817. By dividing these two we have the milling time as 1.616 minutes. But this is for a single pass. So total milling time, let that be capital TM, total milling time. It is 1.616 into depth of cut is 5 millimeters. So the number of passes that will be required will be 5, which is equal to, this turns out to be 8.078 minutes. Let's go back and fill in the answer. Time required for milling the slot is 8.078 minutes. It's very close to 8 minutes. So you can put that also. To learn more about milling operation, you can refer to the NPTEL video Practical Machining Operations, Milling and Drilling from the course Mechanics of Machining. This course is by Professor Uday S. Dikshit. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.